Hello everyone, so today I'm going to talk about the KMP algorithm and I'll be discussing how the LPS array works and what's the intuition behind it. If you don't know what KMP algorithm is, please refer other videos to get a basic understanding and please go through its code. I'm pretty sure you are going to get stuck at this line. This is what confuses many people. So my goal here is to make you understand this line and how it helps in making KMP algorithm a linear time algorithm. Right, so let's dive into the algorithm and let's see how it goes. I'll put it on a pattern string. So let's say we have a string like this. Now these x can be any characters. I am just putting them as placeholders, right? So if you look into the code, there are two pointers. One is length, which initially points to index 0, and there is another pointer which is I, which points to index 1. And we have a vector LPS which has been initialized with zeros, right? So what we do, we move through the whole pattern. So I moves from 1 to pattern dot length, and if these characters are equal, then we update the length and update the LPS. So let's say these two characters are equal, then the length gets updated and LPS of I, so I is 1, that becomes the new value of length, which is now 1, right? And then we increment the I also, and this is how we move forward in the pattern string and keep updating the LPS array, right? So this makes sense. Now what happens if these two characters don't match? So what if the characters at index length and I don't match? Then comes the else part. Now this is the difficult part to understand, right? So we will spend our time just making sure that we get the intuition of how this is working. Okay, so let's move on to this situation. And before I move on, I'll just briefly touch upon what LPS is. Okay, so let's say I have a string. So before I move on to this, I'm just going to briefly touch upon what LPS is and what does it mean if I say LPS of some I, let's say 3 equals to 5. What does this value 5 mean? Okay, so let's say there is a string, something like this, right? And so this is index 0 1 2 3 4 5 6. So if I say LPS of 6 is 3, that means from the beginning of the string, if I take first 3 characters, they are going to be equal to the last 3 characters starting from index 6. So these characters are going to be equal. This is what the values in LPS tell us, right? So what LPS is, longest proper prefix. So longest proper prefix, which is also a suffix. So if we just look at this string, these first 3 characters form the prefix and these last 3 characters form the suffix. So this is a prefix which is also a suffix. That's what the values in LPS tell, right? So if let's say this was the value was 2, then the first 2 characters will match with the last 2 characters. If the value was 0, LPS 6 is 0, that means none of the characters match. So the first character does not match the last character, and that's when we have the value 0, right? So I hope this just reminds you of what LPS was, in case you forgot. And now we can move on to the situation when these two characters don't match. Okay, so now we are in a situation where the characters pointed by these two pointers don't match. So blue character and red characters are not matching, let's say in this case, right? So few observations here. We started with I equals to 1, right? And currently I is at this index, it's pointing to red character. So for all other index starting from 0 to I minus 1, the value of LPS is known, right? That's what we are doing. We are updating the value of LPS I. That's our goal. But starting from I till the end of the string, the value of LPS is yet to be filled, right? So this is one thing, one observation to make. So if you look into the code, it says if length is not equals to 0, which is definitely the case here, length is not equals to 0, then update length to LPS of length minus 1. So what is length minus 1? This index is length minus 1. Okay, we already know the value of LPS of length minus 1. The value of LPS is known for all these characters. This character lies here, so we already know the value of LPS. Okay, But what does it mean to do this? So let's say the value of LPS of length minus 1 is some number. So let's say LPS of length minus 1 is 3, right? Let's say this is the case. So as I explained earlier, in this situation, if LPS of 6 is 3, what does it mean? That first 3 characters are going to match the last 3 characters starting from index 6. Now if the value of LPS of length minus 1 is 3, what does it mean? It means that first 3 characters, so these 3 characters are going to match the last 3 characters starting from length minus 1, right? So this is going to match. Okay, makes sense. Now because these two green boxes are equal, now why are they equal? Because if you look into this code, if pattern I equals to pattern length, then only length was moving forward and I was moving forward, right? So that means, and the mismatch occurs at this particular point, that means everything before that was matching with everything before I, right? That means these two green boxes are equal. Okay, so if these two green boxes are equal, so let me just write these two boxes are equal. Now if they are equal, then what does that mean? It means the content inside them is equal, right? So this thing is equal to this. What means is the property holds, right? So first 3 characters here also match with last 3 characters. Okay, it's this is easy, this makes sense. Okay, so conclusion, all these 4 boxes match, right? So these 4 boxes are equal. Okay, so I hope you are with me till here. So what we did was, we were in a situation where the characters don't match. So we already know the value of LPS for all other index from 0 to I minus 1. We know that the boxes before from 0 to length minus 1 equals to the box before I, right? So the green boxes are equal. Then we looked into the value of LPS of length minus 1. Let's say the value is 3. What it means is first 3 characters in the box equal to last 3 characters. Because these boxes are equal, so here also the first 3 characters will be equal to last 3 characters. That means all these 4 boxes are equal. Okay, so let me try to redraw this thing. Okay, so now let me try to remove few things from this figure. So all these boxes are equal, so that means box 1, 2, 3, 4 are equal. Now let me just remove the box 2 and box 3. So box 2 is gone and box 3 is gone. Box 1 and 4 are equal, right? I can remove this also, right? And can remove this, and what our code says is update length to LPS of length minus 1, which for our case is 3. So it's saying us to update the value of length and let it point back to LPS of length minus 1, which is 3. So what is 3? This is 0, this is 1, this is 2, and this is 3. So now the new length points to this index, right? And I can remove length from here. So you see what happened here. Using this line, we moved our length back to some index, and you see we reused the computation because we already know that these 3 characters are going to match with these 3 characters. So I don't need to move further back. I just need to move enough so that I can restart the matching process without actually duplicating the effort, right? I could have moved back in I also, in length also, and would have done this whole matching for these 3 characters again, but I don't need to if I do this thing, right? So using this particular line, we are able to reuse some computation, and that saves us the time, and that's what gives us the linear complexity. So we are not doing the computation which we have already done. So now what happens here is, we already know box 1 and 4 are equal. We don't know that whether this character and this character match, so we start the whole process again. So if they match, we will increment the length and I, just like the initial block in the code. If they don't match, then again the length will be updated using LPS of length -1, and it will move somewhere back, and again we will try to match, right? So I hope now this makes sense why this line is useful. This is saving us the computation by reusing the information that we stored in LPS, so we don't do the computation again. Now in the code there is one more thing. So if length not equals to 0, then this is what we do. But if length equals to 0, then we directly put LPS of I equals to 0 and move forward in I. One more thing to notice here is we only move I once the value of LPS I is fixed. So if you look in this part, we are not moving I because we are not yet sure about the LPS value of I. That's why we just update the length and we again go back and we try to match them and see, right? But here, because length is 0, we update length I, LPS of I, and now LPS of I is known, so we can move forward in I. But what does this mean? So let's just see that also. If length equals to 0. Okay, so let's say we have a string here, and in this case I is pointing somewhere here and length is 0. So here the length was not 0, length was initially pointing here, but in this case length is 0, and we are saying these characters don't match. That's the whole reason we entered the else block. So these characters don't match. And what is LPS? LPS of I is basically, what LPS says is the number of characters, the prefix, which is also a suffix. Now we are saying even the first characters don't match, like these two characters don't match, so there is no prefix which matches with the suffix, so there is nothing that matches. So the length of LPS of I equals to 0 in this case, and now the value of I is filled for this particular index, so we can move forward, and that's why we can do I plus plus after this, and the whole process repeats. Okay, so that's it for today's video. I hope the LPS array and its working makes sense to you now. Please feel free to comment if you have any questions. See you in the next one. Bye.